Hey there, Cat Baby. Sorry I can't be with you today. My little guy is homesick with croup. But we're going to continue our notes here, and we're going to go back to the idea of area. So the integral from a to b of f of x dx if f of x is greater than or equal to 0. So what I mean is above the x-axis. And if our curve is above the x-axis, then that integral represents the area under the curve from x equals a to x equals b. So take a second and jot that down because we're going to start to evaluate some integrals based on some known geometric shapes. For instance, example 1, we are going to evaluate the integral from -2 to 2 of the square root of 4 minus x squared dx. So right now, we're only able to find the area under the curve if the curves are geometric shapes that we know the area formulas for. So think about this shape, the square root of 4 minus x squared. What does that look like? And hopefully someone said, a semicircle. To which I would say, heck yeah, semicircle. And what's my radius? 2. All right, so we have a curve. And that is my hideous semicircle, but you get the idea. All right, so what's the area of a semicircle? Well, the area of a circle is pi r squared, and we only need half of it. What was our radius again? 2, and I say 2 squared times 1/2 pi, and I get 2 pi is my area underneath the curve, okay? These are the type of questions you're going to see on your quiz, finding the area under the curve using geometry. So let's try another one. Numero dos. The integral from 1 to 3 of x dx. And so you might be thinking, this is just a line. How can I find the area of a line? Well, sillies, we got to graph it. So when I graph said line, when I plug in 1, I get 1. When I plug in 3, I get 3. So my line looks like this. Why can't I draw a straight line on the iPad? This is annoying. Hopefully you get the idea. And we're going to drop lines down. Oh, hey, those are straight. Look at that. All right. So what shape do I have here? You're probably thinking a triangle and a rectangle, which you can totally do it that way. Or I'm going to go with a trapezoid. To which you might be going, oh, I don't remember the area of a trapezoid. Don't worry, I got you. Area equals 1/2 the height times base 1 plus base 2. So keep in mind, these guys right here, those are your bases. Okay, the height is going to be the x distance. So what I have is 1/2 my height, which is right here, that x distance of 2. And then base 1, we'll make that the shorter guy up front, and base 2 going on in the back. So then I simplify this, and we get 4. Awesome. If you have any questions, jot them down. Stop by and see me Monday, okay? And we'll go over it, or just the next time you're able to stop in and see me. 3. The integral from -2 to 1 of pi d theta. But wait, Miss Gutierrez, it's not dx. That's okay. It's still going to be our same representation. I'm going from -2 to 1, and that's going to be pi. It's a constant. So what do we have here? A rectangle, and our area equals length times width, where our length is 3, our width is pi. Hello, answer. Happy Friday. All right, you ready for some you-dos? Here we go. These are our 2 you-dos. 5, we're going to do the integral from 1/2 to 3/2 of -2x plus 4. And then 6, we're going to do the integral from 0 to 3 of the absolute value of x minus 1 dx. Yikes, I forgot my dx over here. All right, so take a second, pause the video, do these problems, hit play again when you're ready to go over them. All right, let's check your answers. So for right here, you should have a trapezoid, okay? When you graph this trapezoid, we should get the area being 1/2 our height, excuse me, I almost called it base, and base 1 plus base 2. So this guy should have gotten 2. Over here, when you go to graph it, this is the absolute value function shifted to the right one. So you're going to have 2 triangles that you're looking at here. So for this guy, that little triangle is 1/2 base times height. And then we're going to go the bigger triangle, 1/2 base times height, and get our final answer as 2.5, 5 halves, 2.5, all that good stuff. So, high five, how do we do? Do we do good? Awesome. All right, so now we're going to move on. Okay, you're going to have some homework that's going to deal with this area under the curve using geometry stuff, and we're going to move on and talk about some other things regarding area. For instance, if I give you this curve right here, all right, I'm going to erase that. Not quite as proportional as I was going for. Let's try again. There we go. And I tell you this guy is 2 and this guy is 1. So I'm going to say, what is the area? So what is the area of this image? To which some of you might be thinking 3, to which I will then challenge you and go, okay, compare that guy to this guy with 2 and 1. Because one of them definitely is 3. Which one is it? It's this guy. This guy right here is 3. That makes this guy what? Oh, that's 1. Yep. All right, so let's give you another one. What about this guy? What if I said this was 5 and so was that guy? What's my area then for this image? And you're probably thinking 0, which is so correct. Because the area for f of x less than 0 is negative, meaning under the x-axis. All right, so now we're going to go into kind of like an exploration type deal, and I'm going to give you a lot of time to do some problems, or not really, you're going to pause it and take some time to do some problems. So let's take a look at this one. The integral from 0 to pi of the sine of x dx. I'm going to tell you that that equals 2. Because if you were to graph it, this is my sine curve, but that goes from 0 to 2 pi. So when I stop it right here at pi, that's 2. So I'm giving you that. That's your given. I want you to now tell me, all right, then what is the integral from pi to 2 pi of sine x dx? And what is 0 to 2 pi of sine x dx? And we'll try to squeeze a third one in here, from 0 to pi over 2 of sine x dx. So take a second, try these 3 problems, come on back, and then we'll talk about them. Okay, so let's take a look here. So now I'm asking you for the area from pi to 2 pi of this graph. So that would be the region to the right that's under the curve. So we're going to say that that is -2. Very good. All right, but what about the whole thing from 0 to 2 pi? And we're thinking 0. I like it. I like it. Now what about from 0 to pi over 2? 1. Yep, I dig it. Nice. All right, so now, boom, try these 4. And then you can even take it to the next page where there's going to be 2 more that are with cosine to try it out. Okay, so again, pause the video, try these problems, then come back and do it. All right, so let's talk about 0 to pi of 2 sine x. That's actually the same thing as 2 with the integral to 0 to pi of sine x. And we know 0 to pi of sine x is 2, and 2 times 2 is 4. Nice. Now this guy over here, What does it mean when I have x minus 2 on the inside? What did that do to the graph? It just shifted the graph to the right. Now, did our limits here? They shifted to the right too. So this is the exact same graph, just shifted to the right. Oh, now we're going negative. And some of you might want to, if that's the top part of sine x, the negative part over here looks like that. So this guy is 0. And so is this guy. And then when we get into cosine, remembering that cosine graph here goes like this, from 0 to 2 pi. So if we're going from 0 to pi, it's stopping right there. So that guy is 0. And then we're going to come over here, and we're going to go from pi over 2 to 3 pi over 2. That's this part down here using the same graph. So that guy is going to be negative 2. So now my question to you guys is, great, we did this whole thing with sine with some area that's provided. But how is sine, or the integral from negative 1 to 2 of x sine x dx different? Do we know a shape for that? We know the shape for sine x. We've known some things now that the top part of sine x from 0 to pi is 2. But x sine x changes it. So what do we have to do? To which you're probably going, Someone yesterday in my other class said product rule, and I was like, silly, we're not taking the derivative. Okay? So the idea is we don't know yet. We haven't talked about any antiderivative rules or anything like that. So what we have to do is we have to go to our handy dandy calculator. So go ahead, get out your calculator, and I want you to do and type in Math 9. Math 9 is going to come up with a pretty little either image straight like this with boxes that you are going to type in, and I think it has even a D box to fill in, to which you would type in the direct integral written above. Some of you might have a computer that comes up NINT. Oh, pause, I'll be right back. Hold on. And I'm back. No more tears. Oh, but now he needs water. Story of my life, guys. Oh, you got it? Okay. All right, we're good. Here we go. Some of you have it come up NINT on the calculator or FNINT. If you have this notation with the parentheses, you're going to type in the function, comma, the variable with respect to that whole dx, comma, lower limit, comma, upper limit. That's what you're going for here. Okay, so that's what we're going to use with all this part. So I want you to try a problem with this Math 9, and I want you to take the integral from 0 to 1 of 4 over 1 plus x squared dx. And that's meant to be a plus sign. My apologies for, it looking like my and. I can't really write on the iPad well. Use your calculator. Again, Math 9 this sucker, and tell me what we get. And we go to type it in, and I really wish I could get a calculator screen underneath of this. I'll figure out a way to make these videos better. And we should get 3.3 decimal places is 142, but you might be thinking, but it's pi. To which I'm going to say, you know what? You are right, and we'll talk more about it when I see you guys in class. So this is the end of the video for the first video today. Your homework is on Canvas, and everything that we've just done is what you're going to have on your quiz next class after we review. So that quiz is going to be all of the rectangular approximation methods, LRAM, RRAM, MRAM, taking a Riemann sum and writing it as a definite integral. And then it's going to be finding the area under the curve using geometry and using Math 9. So the problems that you are going to have on your homework, even though you're already on Canvas, just in case you don't want to go click on that assignment, okay? It is going to be on page 282. And on page 282, we are going to do numbers. Excuse me as I backtrack some. Oops, looking for it on my page. All right, so we're going to start with numbers 1 through 3, add 6. You're going to do 7 through 23, odd. Add 27, add 30, and then you're going to do 32 through 35. Pairing this with the LRAM, RRAM, MRAM homework that you went over today, again, that's your quiz. I encourage you to maybe go back and take a look at problem 19 on that page in the textbook. It's a data chart, and try that with like LRAM, RRAM, and MRAM. Okay, because you will have 3 problems like that on the quiz that could be either functions that you graph or a table. All right, guys, have a good one, and I will see you next week.